Let's talk about work word problems. These are word problems where you are given two or more rates that people are completing a job at, and you're asked to find out how fast would the job be completed if they worked together. And the way we're going to go through these, we're going to follow a similar pattern for all of them. We're going to find out the unit rate for each of the workers. So we're going to find out how much work they complete in X amount of time. And then we're going to end up adding those rates together and then converting it back to the full job. So let's take a look at the first example, see what that looks like. Our first example here, we have working alone, Ryan can dig a 10-foot by 10-foot hole in 5 hours. Costello can dig the same hole in 6 hours. How long will it take them if they work together? So the first thing we're going to do is find out how much each of them can dig in 1 hour. You might be tempted to add them together, multiply them together. That's going to result in us having a longer work time. So we actually need to look at this as fractions first. So if Ryan is able to do it in 5 hours, that means each hour he's completing 1/5 of the project. This is Ryan's. And Castell takes 6 hours to do it, so Castell is completing 1/6 of the whole each hour. So in 1 hour, if they work together, it would be completing 1/5 of the whole and 1/6 of the whole at the same time. So let's find out how much that is. We need to add these fractions together. That's going to be, let's see, that's 6 over 30 and 5 over 30 added together is 11/30ths. So in 1 hour, they complete 11/30ths of the job. So how long will it take them if they work together? Well, we need to convert this to 30/30ths. If working together, they are able to complete 11/30ths of the whole in 1 hour. To find out how many hours total, we need to find out how many of these 11s it takes to make 30, because a completed project would be 30/30ths. So I need to know what I need to multiply this 11 by to turn it into a 30. So to figure that out, we would do 30 divided by 11. And this is some division I cannot do in my head, so let's do 30 divided by 11, and that gets us 2.727. And we're going to round all of our answers to the nearest hundredth for these problems. So rounding up, we have 2.73. And this makes sense. It is less than 5 hours, it's less than 6 hours. If they're working together, they should complete it in less than 5 hours. So this answer does make sense. It would take them 2.73 hours, or 2 hours and 73 hundredths of an hour to complete the work. For our second example, it takes Trevon 10 hours to clean an attic. Cody can clean the same attic in 7 hours. Find out how long it would take if they worked together. So just like the last one, we're going to figure out how much work can they do each hour. So if it takes Trevon 10 hours, that means he is completing 1/10 of the attic per hour. And Cody takes 7 hours, so he is completing 1/7 of the work in 1 hour. So now we need to add these two rates together. To do that, we need to make sure we have a common denominator. So we'll have 7/70ths plus 10/70ths added together makes 17/70ths. Now that we have this, we need to figure out how many of these 17s we need to make the whole 70. Because remember, all of the work being completed would be 70/70ths. So what do I need to multiply the 17 by to turn it into 70? To do that, we will do 70 divided by 17, which is 70 divided by 17, 4.118. And we need to round this to the nearest hundredth, so 4.12 hours is how long it would take them if they worked together. All right, for this problem, we have working together, Paul and Daniel can pick 40 bushels of apples in 4.95 hours. Had he done it alone, it would have taken Daniel 9 hours. Find out how long it would take Paul to do it alone. So a similar pattern to what we've used before. Daniel is completing 1/9 of the work per hour. Paul is completing Paul's work per hour, and then altogether, in 1 hour, they're completing 1 out of 4.95 per hour. We know that this is the fraction that we're going to use for our final rate because this is the pattern that we use for each of the other rates. If it takes 9 hours to complete it, we turn that fraction into 1 over 9 for our per hour. If it takes 17 hours to complete, we turn that fraction into 1 over 17 for our rate per hour. So if it takes 4.95 hours to complete, we're going to turn it into 1 over 4.95 for our final rate. We don't want to have a decimal in our denominator, so let's multiply the numerator and the denominator by 100. So we'll have 100 over 495. And then this can be reduced because both of them are divisible by 5. When we divide them both by 5, 100 divided by 5 is 20, and 495 divided by 5 is 99. So we're going to work with this fraction continuing on because it has smaller numbers. We're not dealing with a 3-digit number now in the denominator. We're dealing with a 2-digit number. Nextly, we need to isolate our variable. So we have our variable in this fraction, so let's kick this fraction over to the other side. We'll now have 1 over p is equal to 20 over 99. Remember, we converted this fraction into 20 over 99 minus 1 over 9. Now, in order to do the subtraction, we have to have a common denominator. We can do that by multiplying numerator and denominator by 11. So this is the same thing as 11 over 99. So we'll do that subtraction. 20 over 99 minus 11 over 99 is equal to 9 over 99. So 1 over p is equal to 9 over 99. 9 over 99 can be simplified to 1 over 11. So 1 over p is equal to 1 over 11. That means p is equal to 11. The time it would take Paul to complete the task is 11 hours if he was doing it alone. Quick recap of what we did because there is a lot that happened here. So let's go back through it step by step. First, we have Daniel's rate per hour. Then we have Paul's rate per hour. Over here, we have the total rate per hour, so 1 over 4.95. We converted this into a fraction that does not have a decimal in it, and we simplified this fraction so that we would be working with smaller numbers. We then subtracted both sides by 1/9 to isolate our variable to one side. So we have 1 over p is equal to 20 over 99 minus 1/9. We converted this to having a common denominator, did our subtraction, wound up with 9 over 99. So 1 over p is equal to 9 over 99. Simplified is 1 over 11. And then this tells us that p is equal to 11. And from there, we know that it would take him 11 hours to complete the job. This is a very similar problem to the last one, where we have two people working together. We know their final rate of working together, but we don't know one of their rates if they were doing the work independently. So we have Rob can tar a roof in 9 hours. One day his friend Kayla helped him and it only took 4.74 hours. How long would it take Kayla to do it alone. So first, let's write out Rob's rate. He's completing 1/9 of this roof per hour. Next, Kayla's rate is going to be completing we'll call it Kayla, 1 Kayla per hour. Adding them together, this would give us 1 over 4.74, because remember, if it takes 4.74 hours, our rate per hour would be 1 over 4.74. And from here, let's go ahead and convert this to something that does not have a decimal in the denominator. So let's convert this. This would be the same thing as 100 over 474. Both the numerator and the denominator are divisible by 2, so that would be 50 over 237. And from here, let's rewrite out this equation. We have Rob's rate, which is 1 over 9, plus Kayla's rate, which is 1 over Kayla, is equal to 50 over 237. From here, we need to isolate our variable, so we subtract 1/9 from both sides, minus 1/9. And that will give us 1 over k is equal to 50 over 237 minus 1/9. We need to simplify this section next. Let's just go ahead and do this the lazy way. We're going to multiply this entire fraction by 237, multiply this entire fraction by 9. So we'll end up with 450 over, let's see, 237 times 9 is 2133. That's this fraction converted. And then this one will be 237 over 2133. We'll do our subtraction. So 450 minus 237 is 200. Okay, yes, we have 213 over 2133. So that is our rate for Kayla. 1 Kayla is equal to 213 over 2133. In order to find what Kayla is equal to, we need to convert this to a fraction that is 1 over k. To do that, we need to divide our numerator and denominator by 213. So 213 divided by 213 is 1. And then 2133 divided by 2013 is rounded to the nearest hundredth, 10.01. And that is how many hours it would take Kayla to complete the task by herself. Because this is the rate 1 per Kayla, so this would be 1 per 10.01 hours. And that is our final answer, 10.01 hours for Kayla to do the job alone. Let's take a look at one more problem today. We have Ryan can paint a fence in 10 hours. Asanji can paint the same fence in 8 hours. If they work together, how long would it take them? This one, very similar to all of our last ones, we'll have Ryan's rate is 1/10 of the fence per hour. Asanji's rate is going to be 1/8 of the fence per hour. So if they work together, we should get a rate for their combined effort. To do that, we need to add these fractions together. Least common multiple is going to be 40, so this is 4 over 40 plus 5 over 40. And adding those together, we get 9 over 40. So that is their combined rate. They complete 9/40ths per hour. So how many hours would it take them? we need to see how many 9s go into 40 to figure out what we would multiply the 9 by to make it 40 over 40. So 40 divided by 9 is 4.4444444, repeating infinitely. So we will round that to the nearest hundredth, and it would take them 4.44 hours to complete the job if they were working together. That's all I have for you today. If you found this video to be helpful, consider liking and subscribing. And if you have a topic you would like for me to cover in the future, please leave it down in the comments below. As always, have a fantastic day.